With Kinesis Firehose, AWS offers a ready-made solution to stream real-time data to a number of convenient destinations. In combination with Amazon OpenSearch Serverless, it can be a powerful tool to store and analyze data on a petabyte scale without writing a single line of code. Go to the OpenSearch service in the AWS console and hit Create Collection under the Serverless section. Enter a collection name and select a collection type. Time series is suitable for timestamp data that is generated continuously, such as logs or metrics. In our case, we choose the collection type search, which is best for working with various data types, such as text, numerical, or geospatial data. Next, we can choose a mode of encryption, either using an AWS-owned key or one that is entirely in our control and hosted on the AWS Key Management Service KMS. For this demo, AWS-owned is sufficient. Subsequently, we can choose a network access setting, which controls from where our OpenSearch application can be accessed. Choose VPC if you need the data to remain private. In our case, we're dealing with public data, so we will choose public. Hit Next and skip the data access configuration for now. The creation can take several minutes. Head over to Kinesis on the AWS console and select Kinesis Data Firehose and hit Create. As a source, we have the option to select either Amazon Kinesis data streams, which would allow us to stream from over 15 different AWS services, such as CloudWatch Logs, CloudTrail, or others. We select Direct Put, as we need a custom input for our purpose. Under Destination, select OpenSearch Serverless. Further down, we have the option to enable data transformation, which would allow us to use a Lambda function to make changes to our incoming data. AWS offers a number of handy blueprints for use cases such as Apache logs or syslogs. We will not be using it for this demo, so scroll down and select the OpenSearch Serverless collection we created earlier and enter an index name. As we selected public when creating the selection, we don't need to specify VPC or security group options. Under backup settings, we can select an S3 bucket to either get a copy of all of our data or limit it to data that has failed to write to our OpenSearch collection. Select a bucket and hit Create Delivery Stream. Go to Lambda and create a function. Select Python 3.9 as runtime and create. Create a Bodo 3 client for Firehose. Put the name of the data Firehose in line 6. For the purposes of this demo, we will simply write a random number. Use the put record method to write the data. In the Configurations tab, select the IAM role of the function. Attach the Amazon Kinesis Firehose full access policy. Note that for production purposes, a finer granularity policy is recommended. Next, head over to the Test tab and execute the function. Now, go to IAM and create a new user that will be able to view our data in OpenSearch dashboards. Go back to OpenSearch and select our collection. Click Manage Data Access and create Access Policy. Select the IAM user we created as principal. Then click Grant and select All on the top half of the pop-up to grant permissions to aliases and templates. Next, on the bottom half, hit Select All again. Select our collection and type test index into the text box. This is the index name we specified while setting up the data Firehose. Then save and create. After that, create another data policy, this time for our data Firehose. Select the same settings for the purposes of our demo. Go back to the Lambda console and run our function a few times to ingest data. Hit Add Permissions and attach policies directly. Choose the OpenSearch Serverless service and select all permissions and resources. Note that for anything other than demos, a finer granularity as well as giving permissions via groups is recommended. Log in with the user we created and head to OpenSearch and open the OpenSearch dashboard URL. Open the burger menu on the top left and select Discover. Click Create Index Pattern. Type in the name of our index and hit Next Step and Create Index Pattern. Now go back to Discover and we will see the data we ingested. Then go to Dashboard, create New Dashboard and hit New. Select Area Chart in the pop-up. Select our index. Then go to Buckets and Add. Select X-axis. Scroll to select Terms and select our field containing the random numbers we ingested. Then hit Update and Save. Name the visualization and save. This has been Flo from floprodev.com. Subscribe and check out my website for more.